The acoustic puncture assist device, APAD in short, is a piece of equipment enabling anaesthetists to perform a more accurate and safer epidural puncture. Its operation is based on the loss of resistance technique, which has proved itself in anesthesia practice for almost 80 years. The APAD measures the pressure in a disposable. This is a disposable extension tube between the epidural needle and the syringe. The disposable is flushed with sterile saline fluid. The pressure measurement signal is converted into an acoustic signal. The higher the pressure, the higher the tone pitch. As the needle approaches the epidural space, the constant fluid flow encounters changing variations in resistance. This resistance is dependent on the type of tissue encountered by the tip of the epidural needle. The variation in resistance means the APAD tone pitch also constantly changes. When the needle reaches the ligamentum flavum, the tone pitch increases considerably, and when reaching the epidural space, the tone pitch suddenly drops. If, with a running pump, the pressure does not rise anymore, the anaesthetist can be 100% certain the tip of the epidural needle is in the epidural space. Simultaneously, the APAD does not only emit an acoustic signal, the pressure is also visible on an LCD screen. The monitoring of the pressure signal is stored on an SD card, which can be printed out later. Before the anaesthetist actually starts the epidural puncture, to check the system he carries out an occlusion test. This involves placing the syringe in the infusion pump with a flow of 100 milliliters per hour. And connecting the disposable to the APAD. The anaesthetist occludes the disposable with his hand while the pump is running. As a result, the pressure in the tube increases, and therefore a rise in tone pitch should be heard. Besides this, the increase in pressure should be visible on the monitor. When the occlusion test is successful, the needle is connected to the disposable. The constant flow of the fluid replaces the conventional stylet. In combination with the APAD, the hollow TUI needle is used from the beginning. As soon as the fluid drips from the needle tip, the anaesthetist can start the puncture. When working with the APAD, the anaesthetist can manipulate the needle with both hands, no matter the level of the puncture. In this way, he has better needle control. As soon as the needle penetrates the skin, the pressure starts to rise. The anaesthetist inserts the needle towards the epidural space, and in the meantime concentrates on what he feels and hears. When the ligamentum flavum is reached, the pressure increases even further. The pressure suddenly drops when the epidural space is reached. At that moment, the anaesthetist stops inserting the needle immediately. If the pump is still running and the pressure doesn't rise again, it's certain the needle tip has reached the epidural space. The graphic representation of the puncture gives absolute confirmation that the epidural space has been reached and can be used to document the puncture procedure. As soon as the epidural space has been reached, the anaesthetist attaches the disposable from the needle and places the epidural catheter. The anaesthetist then attaches the disposable to the catheter and restarts the pump. Due to the catheter's length and limited lumen, the pressure increases. When the epidural catheter is located in the epidural space, a pressure plateau is created. This means the fluid at the tip of the catheter flows out without any further resistance. If the pressure continues to rise, this means the tip of the catheter is not free. The catheter has to be pulled back slightly. All in all, working with the APAD has a number of advantages. The anaesthetist can work with both hands on the needle at any level. The end point of the epidural puncture is absolutely objective. The anaesthetist has control over the correct positioning of the catheter. There is an objective report of the entire puncture procedure. The APAD is excellent for use in training situations. Compared to tactile input, the anaesthetist can react faster to sound. It's entirely possible to differentiate between pseudo and real loss of resistance. For anaesthetists, the APAD enhances their daily practice. But the equipment will always be an aid. The user decides.